finding horizontal or slant asymptotes for the rational function, which again is the end behavior of rational functions. So the first example, again, it comes down to the leading terms. There's the denominator's leading term, and there's the numerator's leading term. And so this is an example of where the degree in the denominator, we'll do it the right same way we did before, the degree in the numerator, is less than the degree in the denominator. Right? The numerator's degree is 1, the denominator's degree is 2. And so that means, and just logically speaking, the parabola is going to grow a lot faster, right? This is the parabola. It's going to grow a lot faster than the line. And so eventually, once I start plugging in really, really, really big numbers, either positive or negative, it doesn't matter, the bottom part's going to get bigger a lot faster, and so the fraction's going to get smaller and smaller. And so as x shoots off to infinity, or as x shoots off to positive infinity, the function, the y value, is going to approach 0. And so we do have a horizontal asymptote at y equals 0, better known as the x-axis. And again, you can always graph it to check it. I'll leave you to do that because we're going to do graphs in a little bit. But if you graph this and check it, the tail of the graph do approach and eventually look like they're almost indistinguishable from the x-axis. All right, next example. This is the opposite. It's almost the flip of what we just did. The numerator is a degree 2. The denominator is a degree 1. And so this is the numerator is greater than the denominator, the degree. And so this is the slant asymptote case. That means it's going to have a slant or oblique asymptote. To find it, I have to do the division. And so I'm going to use synthetic division. I have to divide out either long division or synthetic division. And so I'm going to use synthetic division. My k is a -2, right? Because this is what I'm dividing by. And so -2 is my k, 1, -2, 3. And then I drop my 1, -2 times 1, -2. Add those, -4, -2 times -4. I can actually stop it. I'm going to finish it out. So I get 8. So this one would actually have a remainder of 5. The remainder doesn't matter. What matters is the quotient, right? This is the quotient. That's what this is giving me. And so the quotient is x to the first minus 4. And so that's my slant asymptote. If you graphed it, and actually I might go ahead and graph this one for you. I'm going to graph both the original and the slant asymptote. Can't spit it out. Slant asymptote. There we go. To show you that it is the case. So I'm going to go back in here, clear that one out, retype in my new function, which was x squared minus 2x minus 3 divide by, oops, not times, divide by x plus 2. Parentheses, don't forget to do parentheses x, otherwise it won't follow order of operations. Alright, then I'm going to plug in my slant asymptote, which was the line x minus 4. X minus 4. Hit graph. And I'm going to zoom, I'm going to make my window a little bigger because I can't see the bottom. So I'm going to go down to maybe -20. Just so I can see, there's the bottom part of the graph, and there's my slant asymptote. And so the graph curls around and approaches that line, so there's that line, y equals x minus 4, and it is approaching it on both its tails. It never crosses that line, it approaches it on both of the tails. Alright, and so there's its slant asymptote. Now I didn't ask you, but I'm going to add a third case here, so I'm going to add a part C, because I forgot to put it in your notes. But I forgot to put one in with the degrees are the same. Alright, so I've got my numerator, which is 4x cubed minus 5x plus 10. My denominator, which is -5x cubed minus 6x squared plus 3x minus 2. And so this is the last case where my degree in my numerator is the same as, both degrees are 3. So they're the same. And so in this case, it's the third outcome, the other outcome. I would have a horizontal asymptote. It's the line y equals my leading coefficients. Well, my leading coefficients are 4, -5. And so as x is shooting off to positive and negative infinity, my y values, though, approach -4/5. And so if you graphed it, on the tails of my graph, and if you looked at the table, it would approach -4/5. That's what it would approach, both going off to infinity and going off to negative infinity, and that's the last case. There's an example of each case. So approaching 0, approaching a slant asymptote, and then I added this last one, approaching the leading coefficients when the degrees are the same. All right. And so what we're going to get into is then graphing and finding it and putting it all together. So the last thing for this is putting it all together, graphing my functions, labeling my asymptotes, labeling my intercepts, labeling any holes in my graphs. And so the last part of this is just a bunch of graphs, putting it all together.